In this lesson video, I'm going to go through a couple examples using some applications of probability. Henry took a test for a contagious virus. The test is 98% accurate and 0.5% of the population is infected with the virus. Henry's test was negative. He wants to retest if there is a greater than 1% chance that he has the virus, should he retest. So what is given in this information, yes, we know the test is 98% accurate and 0.5% of the population is infected with the virus. Henry's test is also negative. So we want to look at the chance that he has the virus, so probability that he has the virus given, oh, come on, there we go, given a negative test result. So this conditional probability, I'm looking at specifically out of the people that had a negative test result. So there are 7 plus 9,442 people, or 9,449 people that tested negative. So out of this 9,449, 7 of them actually do have the virus. So what is this probability? Well, 7 over 9,449, if you divide, you get 0.000741 approximately if I round there, which this is a decimal. We want to turn this decimal into a percentage. So I could either multiply this by 100 or move the decimal in 2 places to get 0.074% or 1 if I want to keep going. But this is less than 1, less than a 1% chance. So there is no need to retest. There is a less than 1% chance that he has this virus given his negative test results. All right, example 2. A 45-year-old woman is considering buying a 1-year life insurance policy for $620 with coverage of $200,000. Suppose the probability for a woman of that age living through the year is 99.75%. Based on this information alone, should she purchase the policy? All right, so we have the probability that this 45-year-old woman, oh my gosh, my pen, there we go, lives through the year. It is 99.75% or 0.9975. So the probability that she does not live, right, that's the complement of it. 1 minus this 99.75% or 1 minus 0.9975. So the probability she does not live is 0.0025. 0.25% chance. Now, if she lives, the outcome for her is that she lost $620 for the year. Now, if she does not live, the outcome, her heirs are receiving this $200,000 minus the 620 for the cost of the insurance policy for that year. So her outcome is $199,380 as an outcome. So we really need to calculate the expected value of this insurance policy. Based on the probabilities we have, what is she expected to profit or lose from this situation? So we have the probability that she lives, right? This 0, oop, definitely try to switch colors there. 0.9975 times the outcome of negative $620. And then we'll add that to the probability that she does not live, 0.0025. times the outcome if she does not live, which is 199,380. So her expected value, when you calculate this, is actually negative $120. So based on this, because we have a negative expected value and it's not just a little bit, it's $120, I would not buy, or not the best purchase for her. Not the best purchase. Maybe if she finds a cheaper option, could be a better purchase, but this specific policy may not be the best. All right, last example. Now, of course, there may be other situations that might cause her to buy that. Maybe she has some health concerns. You know, there are other situations. Last one, example 3. Your brother proposes a game of chance. You roll a fair 6-sided number cube, a die. If you roll a 1, your brother pays you $25. If you roll a 2, he will pay you $5. If you roll a 3, he will pay you nothing. If you roll a 4 or 5, you must pay him $10, and if you roll a 6, you must pay him $40. Is this a fair game? Are you going to play this? So essentially, this is another type of problem where I really need to find the expected value, my expected outcome on average for however many times I play this game. So expected, value. So I'm going to multiply the probability of each outcome times the outcome. So luckily, rolling a number on a number cube, the probability of rolling a 1 is 1/6. So let's just kind of make that note over here. The probability of rolling a 1, there's one side with a 1 out of 6 possibilities. So I'm going to multiply 1/6 times the outcome. If I roll a 1, my brother's going to pay me $25. So plus 25, positive 25. And this is if I roll a 1. All right, next. If I roll a 2, there's a 1 in 6 chance that I roll a 2. And my outcome there is that he's going to pay me $5. All right, now if I roll a 3, there's a 1 in 6 chance of that. He pays me nothing, so that's $0. All right, now 4 or 5, that is 2 out of the 6, or 1/3 for rolling a 4 or a 5. And the outcome there is that I pay him $10, so negative 10 for either of those. And then lastly, if I roll a 6, there's a 1 in 6 chance of doing that. I must pay him $40, so minus 40. This is for rolling a 6. All right, so calculating this expected value, the expected value is negative $5. So on average, however many times I play this, I'm probably going to end up paying him about $5 on average. So no, this is not a fair game. The odds seem to be stacked a little bit more in your brother's favor. They're going to pay him out a little bit more. Please let me know what questions you have, and when you're working on specific problems, please don't feel free to contact me, or do feel free to contact me.